A stone column is one of the soil stabilizing methods that is used to increase strength, decrease the compressibility of soft and loose fine-grained soils, accelerate a consolidation effect, and reduce the liquefaction potential of soils. The columns consist of compacted gravel or crushed stone arranged by a vibrator. There are two methods for construction of stone column. First, displacement method, in which the soil is laterally pushed or shifted while making the hole. And second, non-displacement method, in which the in-place soil is taken out during boring to make the hole. The non-displacement method is also known as displacement method. Stone column is very useful for improve the load carrying capacity and reduce swelling of ground. Mix the 1.5 kg of sawdust and 6 kg of water by using the mixer for 5 minutes to stimulate the soil. Next, the mixture of sawdust and water was placed in the aquarium in 3 layers. For each layer, we shake the aquarium to make the mixture compact. We use the PVC pipe to make the hole of the stone column. We penetrate the PVC tube into the soil and remove the soil that are placed in the hollow. The stone column are filled with the ceramic beads. The stone column and simulated soil was tested by adding load on the top of the simulated soil. The load is begin with 2 kg and left for 3 minutes. After the 3 minutes, the settlement was measured by using the steel ruler. The following load is adding until it reached maximum load of 10 kg in this experiment. For every 2 kg of load, the settlement are measured. We need around 15 minutes to complete the adding load on the simulated soil. 2 sets of control were done in this experiment, one without stone column and one with conventional stone column. We are using 2 materials for testing our layer reinforcement stone column. One with the geogrid net and second with the woven geotextile. The material was selected based on their permeability and their tensile strength. Here is how we run the experiment. For the first test, we use the geogrid net as our layer reinforcement. We penetrate the soil by using the pipe tube and remove the soil that placed in the hollow. As the installation of conventional stone column, we use the same method to install this design of layer reinforcement stone column. But the innovation is we put the geogrid in 5 layers of the stone column. We started inserted the ceramic beads with estimation of 20 beads, and then we compact the layer for the 27 times. The first geogrid layer was inserted into the hole. Repeat until the 5th layer with the fill of ceramic beads and compaction of the layer. In this test, we used the geogrid net with a diameter of 38.5 mm. After the stone column is fully inserted, the load of 2 kg is applied on the top of the stone column. After 3 minutes, the settlements are measured and the load is continuously added with 2 kg for every 3 minutes until it reached to 10 kg, while for every 3 minutes the settlements are measured. For the second test, we use the geotextile as our layer reinforcement for stone column. The preparation of the stone column is same as the previously method, but in this test, we are construct and compacting the stone column while the tube is left in the soil. After the stone column is fully inserted and compacted with the beads and geotextile layer, the pipe tube is removed and the load is applied on the top of the stone column. From the graph, it shows the comparison between conventional stone column and both our group materials, which is geogrid and geotextile. We can clearly see that the effect of the stone column on the soil. By using the layer reinforcement stone column, the settlement is less than the conventional stone column. The geotextiles shows not a good result with the settlement is below than the conventional stone column. It makes our objective to make design stone column is better than the conventional stone column was not achieved. We can see that a sudden settlement from geotextile from load 0 to 2.22 kilopascal. It is because, as we can see in the previous method of geotextile layer reinforcement, we are compacting the stone column while the pipe tube is in the soil, and after the stone column is fully compacted, we start to remove the pipe tube. When we are compacting the stone column while the pipe tube inside the soil, the pressure of the stone column is acting on the pipe tube. When we remove the pipe tube and start to apply the load, the stone column is just start to expand to the soil for filling the empty space, and this is the cause of sudden settlement from 0 to 2.22 kilopascal. The good result in geogrid is because we are compacted the beads directly to the soil, and the pressure of the soil is ready to support the pressure from the stone column. The best material for the layer reinforcement is permeable and high tensile strength. In the real world, the geotextile is preferred to use in the road pavement as a separator, while the geogrid is more preferred in the layer reinforcement because it is widely available. We can make the layer reinforcement with the recycled plastic like a plastic bottle so that we can reduce the pollution, reduce the cost of the construction, and increase the ground improvement.